example 12 works like, I could say like before, these composite functions are almost layers of an onion. You're going to work your way in when you're taking a derivative. So I'm going to just to color code everything just to figure out what the outermost function is in this particular problem. In example 12 is the tangent. Then the next function in is cosine, and the next function in is 3x squared. So essentially, I'm going to find the derivative of the outermost function first, which is secant squared, and then of cosine 3x squared. That corresponds to the tangent part of the function. Then I'm going to work my way in and take times the derivative of cosine. Well, the derivative of cosine I know is negative sine of 3x squared then. So that corresponds to the green part. And then finally, it's going to be times the derivative of the blue portion inside, which is 6x. So to highlight that part there, and then you just have to polish it off a little bit. Y prime is equal to, I would put the 6x out in front. Oh, and I forgot the negative there. So the negative, don't forget, from the sign. And then I would do sine of 3x squared times secant squared of cosine of 3x squared, like that. That's part A. I'm going to leave part B and part D for you, and part C to try on your own. So I'm going to ask you to pause the video right now and then try and solve, or not solve, but find the derivative of each of these. And there's lots of layers. You could, for example, for the next one, the outer layer is actually the power that sine is raised to. So just be really careful with that one. And then the next layer is the sine function. And the next layer in is the cosecant function. And the next layer in, there's lots of layers for this one, is the square root part of that. And then the final layer, let's pick another color. What would we do? The orange maybe? Would be this one in here, like that. So I would have to do the power first, then sine, then cosecant, then the square root, which is to the power of 1/2, and then the innermost function. Pause the video, try B, C, and D. I have them here. And the last one is over here. And I think a little bit of this got cut off, so let me fix that. Cosine, like that. B, C, and D. All right, the last example, I put this in here because I had a lot of questions on this on the homework, but I love these questions, and they love them on the AP exam as well, especially in the free response, so I thought we would address them. So first of all, R of x is defined as f of g of x, and s of x is defined as the other way around. So let's just write, I know that R of prime of 2 is then going to be f prime of g of 2 times g prime at 2. And then I'm going to have to go over to the graph and look what happens. For this one, it's going to be g prime at f of 6 times f prime at 6. That's just using the chain rule. Oh, I put an extra parenthesis that we didn't need. And then let's go look. So first of all, let's just highlight. We're finding at 2, so that would be, I need that point there and that point there for sure. I need to find f prime of g of 2. Well, first, g of 2 is 7. I can see that here. That's g of 2, 7. So that means f prime of 7 times g prime at 2. Now, remember, that's the slope here. So the slope at 7 of the f function, the f function is right here, and the slope at 7, it looks like a positive 1. So 1 times, and then g prime at 2. So then we need to find the slope up here at 2, at that point right there. So that means it's going to go down 1 over 2, so that's negative 1/2. So that means this whole problem is going to be negative 1/2. For the second one, let's do the same thing again. So just to practice a little bit, what are the points that we're interested in? I need to find f of 6. So f of 6 is right here, and f prime of 6. And I need to find g prime. So f of 6 is 5, it looks like. G prime at 5. And I also need to find f prime at 6. So g prime at 5, let's see, that's right there. What's the slope at that point? Well, the easiest one I can find is really the slope of this entire segment. So that means I'm going up 3 and over 5 of that, and it's a line segment, that's how I know that. So that is going to be 3/5 for any point, by the way, from 4 not inclusive up to 9 would do that. And then times f prime at 6, that's right here, the slope of that line right there is 1. So therefore, it's going to be 3/5.